Okay, so in the last video, we proved that, we proved the quadratic formula, the well-known quadratic formula, right? I'll just write it out here because we're gonna need it for today's video too. So x is equal to minus b plus or minus the square root of b squared minus 4ac upon 2a. Go ahead and watch that one, right? Yeah, because it's a neat proof. It's not that long. It's good enough. Basically, we completed the square for it. Okay, now moving on. So today our goal is to prove. Okay, why is this out of focus? Okay, our goal is to prove the Vieta's formulas. If you are unaware, then oh well. The Vieta's formulas are basically, they give us a relation between the roots of an equation and the coefficients of the variable. So for a quadratic, we have if we have the roots alpha and beta, right? For quadratic, then we'll have alpha plus beta is equal to minus b upon a, and well, we have alpha times beta is equal to c upon a. That's that's the Vieta's formulas for a quadratic equation, right? Let's just write it here. The general quadratic equation, ax squared plus bx plus c, right? Okay, so now we move on to doing this. So pf, first of all, remember to write that stuff, okay, let's use a different pen for this. Maybe. Okay, so the proof is as follows. Okay, so we just plug in really. So we know that the two roots of this equation right here are, okay, so x can be equal to minus b either plus square root of b squared minus 4ac upon 2a, or it can be minus b minus the square root of b squared minus 4ac upon 2a. So we'll assign this the alpha's value and this beta's value, and of course it's easy enough to see that this can be beta and this can be alpha, because they're really commutative quantities. Alpha plus beta is the same as beta plus alpha. That's easy enough. Okay, now moving on to proving them actually. So let's prove the first one. Let's call this 1, let's call this 2. So for 1 we have, okay, right, so 1 says alpha plus beta is equal to minus b upon a. Well, okay, let's see. Alpha is minus b plus square root of b squared minus 4ac upon 2a plus, now we'll have to put in the parentheses. Do not forget to include these, okay, plus minus b minus the square root of b squared minus 4ac upon 2a. I'll just put parentheses around this one too, and of course our claim is that this is equal to minus b upon a. Okay, let's simplify. So this becomes minus b and minus b. So we have, okay, so we can take a common denominator. They're both the same. So minus 2b, easy enough to see, right? Okay, then we have a minus b squared minus 4ac, and then we have a plus b squared minus 4ac. Convenient, they cancel out, huh? Well, then this just becomes plus 0 upon 2a, and this is extremely small. This is extremely easy. So you can cancel out the 2's, right? Yes. So we have a minus b upon a is equal to a minus b upon a. Pretty cool. Now moving on to proving the second part. Okay, and we're still using the same quantities for alpha and beta because I'm lazy to write them out again. So yeah, let's see. The second part states or claims that alpha times beta is c upon a. The product of the two roots is c upon a. Okay, let's see. So, well, our first one, let's just write it out, right? Writing things out is an important part. 4ac upon 2a. This simply multiplied by, let's just put a concatenation dot there, minus minus the square root of b squared minus 4ac upon 2a. And our claim is this is equal to c upon a. Okay. Well, for the denominator, we simply have 4a squared. Is it? Do we not? Yep, we do. Okay. For the numerator, on the other hand, okay, so we have to use an identity. I'm going to write this in terms of m and n. So m plus n times m minus n. Okay. N equal to m squared minus n squared. That's a well-known identity, the difference of squares. And well, we know that this is if we say that this is m and the discriminant with the square root is n, then it's easy enough to see that this is equal to, well, minus b squared. But that's not really, yeah, this is just b squared. And then we have a minus b squared minus 4ac. Great. This is equal to c upon a as we claim. Of course, it's easy now to see that these cancel out, and we have a 4ac upon 4a squared is equal to c upon a. The 4's cancel out, so we have an ac upon a times a. Let's write a squared as a times a equal to c upon a. Okay. And we have c upon a is equal to c upon a. And there's 2. So we have hence proved vietas. As that's pretty nice. Yeah, it's cool. Pretty nice.